Okay, so thanks for having me, everyone, first of all. This is about software, and I'll just preface this by saying I'm not a user of BIM myself, but I do see the use of it and the power of having it a part of what we do. And I know that it's used behind the scenes on a lot of projects that we deliver. So my role with the city is managing the city's capital building projects. So I look after most of the city's major building infrastructure. So that includes civic facilities, arenas, even just small bathrooms at parks and so on. So anyway, give you a bit of a idea about me. So I grew up in Kamloops. I wasn't born here, but I grew up here. I went to high school and university here. I'm a graduate of the TRU program. It was, as Bindi mentioned, it was EDDT at the time. It was a 3-year program. I don't know how much it's changed since I was there, but so I have a pretty good idea of what you guys are learning, and hopefully my presentation can show you a bit about what you can do with it and where you can go. So I also started, unlike most of my my peers, I was a tradesperson before. I worked as a carpenter. So I was a carpenter and joiner for probably 4 years before I got into design. So the way I went about doing that is I started working in trades, and then I realized that I kind of wanted to take it to the next level, and I wasn't sure how to do that. So I decided, hey, I'm going to go back to school and give this a try. So then I ended up taking the EDDT program and moving on from there. So I kind of bounced around a bit. I started as a doing building envelope and structural design for RJC in Victoria. So I did structural restoration work and building envelope work, fairly complex envelope stuff. We didn't do a lot of stuff on that in university, so I was a little out of my element when I got there, but you'll see that in most cases when you get out. You'll have a lot to learn when you get out and adapting to how things are done in industry. So I did that for a while, and then I decided that I wanted to change gears, and I ended up moving to Vancouver and work on railway projects. And I can say that railway projects are probably some of the most diverse projects you'll end up working on. They're kind of like their own little cities. They have their own buildings. They have obviously heavy-duty civil infrastructure, the rails themselves, the earthworks, all that. They even, in some cases, they own water systems and stuff like that. So they're not just moving trains. They've been around for so long. They have a lot of different layers to them. So that kind of segued into me ending up working for the city. So one of my colleagues from the past reached out and asked me to come and join the team, and I ended up doing that. So I'd never worked for a municipality before. I'd worked with them a lot. There's a lot of crossover with railway stuff, so I had an idea. But there was a lot for me to learn when I started. And I started with the city in around 2014. So anyway, that's a little bit about me. Give you guys a quick overview of what I'm going to talk about. My focus is more about, instead of like technical design stuff, it's more about implementation of these things and how it all comes together and how we look at it and move through these projects. So the first note I need to sort of hit on is project management, and that's kind of my role at the city, and then I'll roll into the capital planning, sustainability, which I'm sure you guys hear a lot about, which is great, but what I want to kind of express to you guys is how we actually get it done. It's a little more difficult than it sounds getting it rolled into the project. So anyway, I'll touch on that. I'll talk about building durability as well, building maintenance, and then the reality of the design process, I'm calling it, and then the role of technology. So to jump right into it, so as the owner's project manager, just to give you guys a bit of context, you kind of get pulled in a lot of different directions. So, but it doesn't matter. You see there's quite a busy chart here, but you want to be careful not to dabble in too many of those bubbles, because you get sucked in and then you don't get anything done. But you got to recognize the importance of everybody's role, and I make mention of that by saying even the guy that's providing the steel can, take the project off the rails as just a supplier. So you got to regularly be aware of that and make sure that you have the people in place to make sure all these things are getting done and you're not getting yourself in trouble. So I made another point here. The owner's project manager's role is to do nothing but be responsible for everything. So you see on the chart there, everybody in some way, everything affects and runs through you. But you have to be careful about not getting sucked into those little details. So keeping in mind, having a coach mentality is kind of how I do it. Instead of just pushing things off, I try to, work with the team and monitor the health of the team, and hopefully, the architect and the general contractor are open with issues and we can work through them as a team, because that's, at the end of the day, that's what we want to do. Everybody has the same goal in mind. You just got to keep that in perspective for everyone. So again, and having that team mentality fosters trust and mutual respect, and then you're more open with each other, and it's easier to work through problems as they come about. Okay, capital planning. So this is the tricky part. So a need or a want is identified. The artistic people have ideas, and the technical people build boundaries around them. So what I mean by that is usually these great ideas come about, and then an engineer comes and says, oh, you can't do that because of these reasons, you can't do this, you can't do that, and we have to pull it back until we get it in alignment with something that works. Not every design works for every site. You can't put sustainability in every single project. You have to just be conscious of that. So once we have the boundaries or constraints identified, we cycle through what the needs and wants are. So the needs are kind of what's going to define the business case of, we have, use the pools for example, because that's going to be what I'm going to lead into. So we have all these tournaments coming, the population of Kamloops is growing, we need another pool. So those are the sort of things that would be in need. So there's the base need, we need a pool. Moving on from there is now the wants start to roll in. Well, it would be nice to have a slide, and it would be nice to have maybe a spray park outside of the pool or something like that. So these are the wants start to roll in. And then once we have all those on the table, we look at the costs and we gasp, and then we start to figure out how we're going to get that done. And it's important to have all those wants on the table, because we can work towards that in future projects. We may not be able to get it all done right away, but at least if we think about it and we plan for it, then it can happen later. So once that's all done, then we'll put together a business case, and that'll go forward to City Council for consideration. So, I've really tried to cram a lot in here, but there's a lot of complexity and thought that goes into these before they go to council. I know sometimes people that are from the area, some ideas might seem like they just came out of nowhere. But really there is sometimes years behind thinking about these things and planning them. Okay, integration of sustainability. Reduce, reuse, recycle. So I just wanted to shed light on this. We like to think of these sustainability projects about the things we can see and touch and feel, and okay, let's do solar panels, let's do this or let's do that. But sometimes you have the biggest impact in a place you don't expect and you can't see. So I have a few examples here of projects. The first one with the excavator with the crusher there is not actually from a project. That was just an example of concrete crushing, which I'll lead into. The other two photos are of our west side pool. So some of you may be familiar with this project. We did it over the last few years. So West Side Pool, we preserved the pool and we basically rebuilt the frame and structure. This created a lot of waste because all the wood material that came off the building, what are we going to do with it? So I think that's something that gets kind of lost in the sustainability piece sometimes. This is a massive amount of wood to get rid of. What do you do with it, right? So you need to look at the demolition and go through these pieces and see where there's value. Those beams, maybe they're not good to support a roof anymore, but they can be used for other things. So let's just not throw them away. So anyway, and I'll lead into a few examples here. So an example with the concrete crushing and reusing materials. So the city, I don't know if anyone's familiar, but we rebuilt the retaining wall that's on the side of the old courthouse a couple of years ago. So a lot of people probably didn't pay too close attention, but the wall was getting pushed over by the massive trees there. We had to remove the trees. There was a bit of issue around anytime you remove a tree, there's a big issue, but there was a lot of thought put into it. So what we did is, what do we do with these big, healthy, mature trees? Like, we don't just want to cut them down and send them through the chipper, right? So what we did was we went through and we topped the trees in the longest segments the faller could handle, and then loaded them on the back of a truck, and then they were used to build the amphitheater up at Kenneth Cartwright Park. So they weren't just thrown away. So the other thing we did is we take the old concrete, and that was on that first slide, and we bust it up and we use it on our roads. So we make what we call RAP, which is essentially reclaimed concrete and asphalt material. So when we do a road project, we'll go through and we'll mill the road, we'll collect those millings, and we'll use them as road base for other projects because there's still value there, and we'll use the grinded concrete and mix it in to try and reuse it instead of just wasting it. So again, I led into this. Not all sustainability concepts are good for every project. So they need to be clever, have a clear and measurable benefit, and be financially viable. It's easy to get sucked into, like, as I said, the really fun stuff like solar panels and stuff like that, but you want to be conscious of what your payoff is. So if, for instance, a few years ago, if you're putting solar panels on, say, an asphalt shingle roof, it may not be that smart because the payback period for the solar array is maybe 30 years, but the roof is only good for say 20 years. So do you want to be hauling all those solar panels off? So you want to make sure that when you do that, that the assemblies you're putting them on are meant to last at least through that payback period. We would like to also, another thing I'd point out here is when you can't do all these sustainable pieces, sometimes it's good to separate them and say, okay, well, we can't do this now, but what do we need to do so that we can do it later easier? For instance, this is the roof of West Side Pool. So you guys saw the deconstructed building. So this is the new flat roof and frame, and those steel pieces projecting from the roof are supports for the solar array. So what we did do is, well, we had the building apart. We're like, okay, well, we can't buy all the solar panels now, but what we can do is make space for the inverters. We can integrate the mounts to the structure, and we can run the conduit to feed the cable through to get them connected. So now, this actually went forward as a supplemental. If council accepts it, we essentially can mount the PVs, run the cable, and hook it up to the electrical system. It's all been considered as part of the original construction. So this is kind of a way of trying to, like, okay, well, we can't be totally sustainable and get it there yet, but if we include these things now, then it makes it easier for us later, because you can't go put this on later. And if you guys don't know, like, the reason those have to be so significant is the wind uplift and snow drift can cause a lot of grief to the structure. So it's not a matter of just easily bolting down a jack in this situation. There's a lot of wind load through here, so they have to be properly anchored, or the solar panels will go flying away. We also have to get creative because people like to steal them. So we put tamper-resistant hardware on there and just try to slow people down. There was, I think, the Sing Bowl a few years ago had solar panels on it, and those were taken, which was not good. So $100,000 worth of solar equipment was taken, and whoever did it knew what they were doing because they got the inverters, the cable, the panels, everything. You know, they didn't break any locks. So just things to consider when you're doing these things is they do have a lot of value to them, and people will take them. Okay, so whether you're renovating an old building or constructing a new one, the best way to reduce the consumption of energy is to reduce how much is needed. So this is especially important for climates like Kamloops, where you see kind of the extremes. It's either really, really, really warm or really cold. So when you do the envelope and structure, you kind of got to be careful with that and think about the climate when you do it to get the maximum benefit out of it. So building structure also plays a critical role. If you make the building a really weird shape, it's going to be harder to heat and cool and get air on all the spaces that you need to. So if you want to do sustainability, like major sustainability things, it's good to think about it at the start because this will also affect the shape. So I use an example of thermal massing, which some of you may be familiar with. It's basically just a big, to put it very simply, section of concrete that absorbs heat all day and then radiates it back out into the building. So that obviously has a lot of effect on structure. So if you want to do that, you need to think about that and roll it into your original plan. Here's an example of the progression of West Side Pool to show you guys. So you can see the frame, the insulation and stucco layers starting to go on the blue skin, and then the finished stucco product. So there's a lot of different layers there. So on this situation I mentioned about like the climate of Kamloops, you also have to think about the use of it. So with a pool, you're maintaining this constant balmy environment. So you have to be really careful about where the condensation points are and control the water. Ideally, you want it to leak to the inside of the building. If you can see the wall sweating, you've kind of done your job. The problem is when it gets stuck in the wall and then you get rot. And I'll show you an example of that coming up. The other thing, and I think this is where everybody gets kind of the fun part of sustainability is, and the place where everybody gets stuck is the mechanical system. So yeah, you can put new boilers, air handlers in, special lights and stuff like that. But if you take the right mindset from the start and try to reduce the number of parts you need, that sometimes provides a greater benefit. I use an example of strategically placing windows, and maybe you don't need a light all of a sudden. So thinking about that when you're going through is critical. One example for West Side Pool, one of the top advice we got from the mechanical designer was put a cover on the pool at night. Seems very simple. We don't have a cover. When the pool's sitting there not used, all that heat's just leaching off the pool and getting up into the superstructure. And if we could cap it off, then the boilers wouldn't work as hard to maintain a temperature that nobody needs at 2 in the morning. So just a simple little thing. But again, it's not the really exciting thing. It's just adding a pool cover, right? But little things like that can make a very big difference. Whereas if we're investing in a boiler, that could be, well, I know what they were for West Side Pool. They were $120,000. That was $15,000. So it's a lot cheaper, and you get comparable benefits from it. Okay, building durability. So this is one of the main glue lambs on the end of West Side Pool. So those of you that don't know what happened here is there was a building envelope failure over years and years and years of condensation. And this is an example of what I was talking about not controlling the dew point. So when moisture ends up where you don't want it, especially on cellular materials like wood, you end up with rot. And a lot of times they're hard to find because they're concealed. So in the example of West Side Pool is this was not apparent for a long period of time because it was concealed in the walls. The structure that could be seen was fine. There was multiple inspections done. There was no reason for concern. And then a few things came up that led us to believe there was another issue. And the problem here was actually an air leak, not a water leak. People were thinking when you see a leak in the pool, you automatically think, oh, well, it's an exterior leak. It was an internal leak. Air leak that created a lot of condensation, and that's how we ended up with that. But the beams were, at the ends especially, they were quite damaged because that's where the air got concentrated. Building shape also played a role in that. It had a slanted roof, so everything got trapped in one corner. And if you look at the rate of the damage around the building, you can see how the shape played a role in the damage to the envelope. So when we're doing these things when we're taking these forward at the city, we try to make sure that these materials we're picking they work with the use of the building. So we have a pool, for instance. We shouldn't be building with wood. We should be using steel or composite materials. I'm not saying you can't use wood, but sorry.
I'm just curious. Have you guys looked into like smart sensors or anything for these?
Yeah, to monitor it. I mean, for this example, it was obviously it was too far gone already, but putting it into the new building makes sense to monitor. I know what you're saying, monitor moisture points, and we're getting a lot of water condensation here, what's going on, and then you can kind of target your repair a little bit, but we haven't actually done it here yet. I did it when I was a consultant, but we haven't brought it forward to buildings yet. It's a good idea though, for sure. oops. Am I missing a slide? No, okay, then we're good. Okay, so this is where I'm going to kind of tie it into the BIM stuff. So the reality of the design process. So owners like to change their minds. So I can tell you that as a representative right now. It's not necessarily me that's doing it as the owner's project manager, but the people that I'm working with will. And they don't understand all these drawings all that well. So probably the hardest part that I found in my career was not the technical aspects of it. It was trying to make sure that it met a budget. So owner would say, I want $300,000 with a building. That's kind of the hardest challenge I've ever faced. You can always find someone that will be able to design a beam to, support a certain span, but can you do it for a certain budget? That's the really big challenge and struggle we have, is trying to meet that budget. Especially with the city, we're so under a lot of scrutiny with the budgets. So we have to make sure that when we take forward a number that it's not going to change. The role of technology, so this leads into a bit of what I was saying before, is when the owners like to change things, and some owners don't understand how this all works. So we may say, I like what you did, but I don't like that wall there. I actually want to change this space. Now I'm going to put a daycare in there. And for, a lot of the designers in the past would roll, oh my God, now I got to redo everything. And I just used a little slide here as an example, but you see the impacts that moving a wall would have. The mechanical bulkheads got to move over, the electrical systems got to move. It affects so many things. So being able to deal with this in an easier way with what the software is doing now is I think is awesome, because we're definitely, with owners will say, okay, we want this move for the daycare, and then it has to be done. I need it next week. So, the time expectations are a huge crunch as well. Anyway, so that's kind of my presentation. So in closing, I'd just like to leave you guys with just a few notes. So try to plan ahead with the mindset that the building will evolve over time. So like I used as an example with West Side Pool with the solar panels, try to think about what it might be in the future and allow that to happen. Set clear objectives and try to stick with them. So that kind of leads to my point about needs versus wants. Like, what are they? And if you have core objectives, try to hold on to them and keep them in your mind when you're moving forward with the project. Be prepared to take a few steps back before you can take steps forward. So again, talking about the design process, you may, in your mind design the perfect structure and everything's great and the owner doesn't like it. And now you got to go back and start modifying it until you get it right. Be smart with sustainability. Look for ways to make the biggest overall impact, not what everybody's going to think is cool. Try to get that in there, but also sustainability, I think, needs to be like a mindset that runs through the entire life of the project. And that's why I wanted to show you guys the demolition, because I think that's something that gets forgotten about and has a big impact. Be mindful of how the building will be run and maintained. Probably some of the best advice I got being the city's project manager is from our operations people telling us, hey, this valve doesn't work here, this doesn't work. And knowing that going in, you got to remember at the end of the day, it's for them to operate. And if we're making it hard for them, it's not going to be a success. So don't get too invested in one idea. Be collaborative and seek others' perspectives. So don't get fixated on something. Try to be inclusive and think about other things. A lot of people will bring stuff to the table that you never even thought of, and I've changed my mind a lot by asking that question. So just keep that in mind. Take advantage of the tools you have. Be proficient with the software, and it'll make you kind of the go-to person. When I was designing, I kind of was that person. I got really good with the software I was using, and I was able to just kind of be the go-to person and evolve from there. So work my way out of design and into project management. This is kind of my most important point, is go to the sites and seek feedback from the contractors. I know there's a few contractors here. They have important information to share with you guys. If you don't go to site and you don't see how things are built, then you're not going to be as good of a designer. When you think about how the project and pieces of the project might go together, you'll make everybody's life a lot easier. So going to site, talking to contractors, asking for their perspectives and opinions on things. You don't always have to see eye to eye, but at least if you seek their input, you may find that it's quite beneficial to you as a designer or even a project manager. I've got great advice even on that from contractors. So anyways, anyone have any questions? Good.
You touched on it a little bit, but life cycle analysis.
Mhm.
Do you, or does Kamloops, I guess, have any thoughts on writing a spec for, say, facilities management models, operations maintenance?
Yeah, we're kind of getting there. I think some of the buildings planning stuff is a little behind, so we're starting to get in front of a bit of that and plan these life cycle costs a little more. One example of it is our roofs. We have a lot of roofs that need to happen, and instead of just being reactive with stuff and say, oh, we have a roof that's damaged, we need $500,000 to fix this roof, and just being reactive with them is been recognized by both finance and the buildings team is it's not a good way to do it. So we're trying to evaluate these way ahead of time and have a rolling budget built in to go through and deal with those. So, but we haven't looked at specific softwares or techniques or methodologies to get too deep into that. Now we're just kind of getting started. So
Operations maintenance, so a building, 80% of a building's cost through life cycle analysis, right? Through life cycle is post-construction.
Mm-hmm.
That's, a huge amount. So this is where kind of the real holy grail of BIM is, as we say, is life cycle data.
Mm-hmm.
I know in Alberta, where I'm from, so the government has sort of put a big initiative forward. It's just something that I think is overlooked a lot.
I agree.
I was just curious as to where
Mm-hmm.
the BC government is kind of sitting with that. So
I can't speak for the BC government. I can speak for the city and say that we recognize that as a problem and we're trying to work on it. So trying to get people's and council's mindset shifted from don't focus so much on the capital cost, focus on what the life cycle cost of the building is. Don't look at it as it's one hit of like $4 million. Oh God. No, look at it as, the project in its entire lifespan. So
Right on. Thank you, Matt.
yeah, no problem.
Very good.
Thanks everyone.